Okay, thank you, Frank. Okay, hello everybody, and welcome to the November 2021 Zoom meeting of the Central Florida Astronomical Society and preview, foreshadowing, whatever you call it. This may be our last Zoom only meeting. We'll talk more about that in a bit. We got a great program for you tonight. After some important announcements, we're going to have a great talk about the lunar South Pole environment. Then we're going to have our lineup of mini programs. Derek's got some member Astrophotos and sketches and is going to do a tonight's sky. I'm going to spend just a minute on the moon. Actually, maybe it'll be another minute on the moon, more to the point. John Pinto is going to do a book review about the Observer's Handbook, and then Mauricio is going to give us an update on CFAS outreach updates. Just your monthly reminder, official communication is through the Groups IO mailing list. There will be quite a bit of official stuff going out in the next month or two. So if you have not subscribed, make sure you subscribed or make sure your spam dragon is not eating it. For those watching YouTube, you can join CFAS at cfas.org on our website, cfas.org. So for announcements, our first big announcement is our next meeting is December 15th, which is a week later than normal. That's going to be our annual holiday party. We are going to be meeting in person this year at the Geneva campus. We are going to have an outdoor seated catered dinner, door prizes, and bling to give away. And bring a scope since it's at the Geneva campus if you want to do some lunar or planetary observing. The moon's going to be quite bright. Then there will be a meteor shower just petering out, but with the bright moon, I wouldn't hold my breath on meteors. But the moon is always cool to look at. I love looking at the moon. The planets will be out, and it'll be a great time together. Just we're very looking forward to that. We don't have all the details planned, but we are going to cater important ideas. We are going to cater, so you do not have to do potluck. We will not have 800 desserts and 3 pieces of fried chicken for the meal. We'll have something well balanced. Let's see, we'll send out more info via Groups IO, and we're going to be trying out our new RSVP system. So Sharife is putting together a system where you can log in and say, yes, I plan to be there, and that will allow us to know how many people are coming. For potluck, it really doesn't matter. If 10 people show up, there's enough food for 10 people. If 100 people show up, there's enough food for 100 people. Since we're going to be catering, we do need to know how many people are coming. You can bring guests, of course, and you'll be getting details on that, of course, via the Groups IO. The other big announcement that we're very happy to be telling you about is on January 12th, we will be back in the planetarium. So we're very excited about this. The college is back into full swing. Of course, you know, the December meeting is the holiday party, so we might have done it in December, but it makes more sense to go out to Geneva and do that again. This is also going to be another opportunity. We're going to introduce you to our RSVP system just to let us know you're coming. CFAS has grown a lot during the pandemic. We have over 140 members now. Most likely all 140 of you are not going to show up at the planetarium at once, but we want to make sure we find out that 100 of you are showing up. We don't want to wait until 7:05 the night of the meeting to find out that we're going to have that many people. So we have a couple of contingency plans, either moving to another larger location on campus or having an overflow room. We're going to cross that bridge as we get to it, but the RSVP system will allow us to know, oh, well, there's 50 people coming, or oh, there's 150 people coming with guests, and we will plan accordingly. Our last announcement before we get into our main program is we are still tentatively on for our star party this Friday being the day after tomorrow. Show up at the planetarium anytime around 6 o'clock or later to set up in the parking lot out next to where the planetarium is, where we were last time. If you're not sure where that is, go to the planetarium and look for a bunch of people with telescopes in the parking lot. That'll be us. Right now, the weather looks kind of iffy. I'm about 75% confident we may have to call it off, but that last 25%, you know how the forecast can be around here. So we're going to wait until tomorrow or Friday, no later than 4 o'clock Friday. Actually, probably no later than Friday morning, we'll be able to call it and let you know if we're just going to say, no, the weather is going to be bad. by the way, if the weather is bad, it doesn't matter. The planetarium, it doesn't matter if it's rainy or cloudy inside the planetarium. And the college has returned to the regular planetarium schedule. So you could come out for the next planetarium show on Friday. Planetarium shows are free for CFAS members. And Derek, I believe the planetarium shows are at 7. I've not looked at that schedule.
No, we're only doing one show at 8:30 this week.
8:30.
Yeah.
Okay. Okay. So if we get clouded out, come by the planetarium if there's seats available, and that would be another way for us to get together. Okay, that's enough blathering on from me. It's time for the main show. I'm going to let our Vice President, Trisha, introduce our guests.
Hey guys, can you hear me?
Stop sharing my screen in a minute. I hear you great.
Okay, so welcome everyone for coming tonight. We have a localish guest, Dr. Dan Batcheldor, resides over here with me on the Space Coast. And also, I think, Frank, you moved over here too. So you're a Space Coast resident as well, right?
That's right.
A little bit of Space Coast is the best coast. A little bit about Dr. Dan Batcheldor. He was previously the head of the Department of Aerospace Physics and Space Sciences at Florida Institute of Technology. He moved to the US in 2004 and won multiple opportunities to use the Hubble Space Telescope. His research has covered all the sci-fi classics of black holes, planets around other stars, and my personal favorite, Mars. He is currently supporting the Artemis mission to land the first woman and the first person of color to the lunar South Pole in the coming years. Dr. Batcheldor received his PhD from the University of Hertfordshire in the UK and was a research scientist at Rochester Institute of Technology before moving to Florida. He is author of Astronomy Saves the World, Securing Our Future Through Exploration and Education, which I will post a link to in the chat, that advocates for the introduction of astronomy as a part of core science school curricula, thus improving the scientific literacy of the general public. Please post your questions in the Q&A window and we'll make sure to get them answered for you towards the end of the program. So without further ado, let me go ahead and welcome Dr. Dan Batcheldor.
Well, thank you very much, Trisha. Can everybody hear me okay? I can see my microphone thing going up and down, so it should be all right.
Great.
All right, thank you so much. So it's wonderful to be here. I really appreciate the invitation and how this talk is coinciding with lots of lunar activities it appears that you all are doing. So I wanted today to kind of go through some of the challenges that the crews will be experiencing when they touch down for the first time at the lunar South Pole as part of the Artemis missions. Currently over at the Kennedy Space Center, it's a very exciting time. We, at this very moment, have 4 crew waiting for launch in the Crew 3 mission, which is SpaceX Falcon 9 Dragon going up to the International Space Station. That crew is currently on board with a potential launch time of 9:03 p.m. this evening. It's raining pretty hard here in where I am in Melbourne, so I'm not sure what your observing conditions are going to be for that launch. But also, it's wonderful time to be observing the moon. Those of you that were lucky enough to see a bit of a clear sky last night, as I were, was able to see just after sunset around about 7 p.m. and this is why we like the clocks to change, right? We saw Venus just off of the horizon, followed by the moon, and then Saturn and Jupiter were chasing up the moon as well. So it's actually a really good time of the year to be observing the planets and the moon at a very hospitable time during the day. Anyway, I'm sure most of you are aware of the nuances of the lunar orbit, but I wanted to present this very wonderful video to start with, just to remind ourselves of all of the intricacies of the lunar orbit, because even though the face of the moon that we see is almost constant, because of the moon being tidally locked to the Earth, which means that the moon's rotation period matches its orbital period around the Earth, which means we're always seeing the same face of the moon. Because the moon has a, as all astronomical objects do, has an elliptical orbit and an inclined orbit as well. That means that we see actually more than just one half of the face of the moon. Because of this ellipticity and inclination in the moon's orbit, where sometimes the moon is closer to the Earth, sometimes the moon is farther away, that means that the moon is actually moving faster when it's closest to the Earth and slower when it's farther away. That's actually one of Kepler's laws, Kepler's second law. This means that when the moon is coming towards us, we get to see a little bit more of the approaching side. And when the moon is actually moving away from us, we get to see a little bit more of the receding side. Now, because of the inclination of the moon's orbit as well, it also means that we get to see a little bit more of the northern and southern regions of the moon due to this kind of wobble, apparent wobble in the orbit of the moon itself. So this is the process of libration, and it actually allows us to see about 93% of the lunar surface without having to send a spacecraft around the back of it. So you can see here the moon changing its distance from Earth. So as it gets closer to Earth, this is where we get the supermoon type events. And you can also see here the type of inclination that the moon has with respects to the Earth. And you'll notice here the blue dot is actually the position of the Earth in the lunar sky, whereas the orange dot is the position of the sun in the lunar sky. The Earth is almost stationary when you are standing on the surface of the moon because the moon is tidally locked, and the sun takes 27.3 days, Earth days, to make a complete rotation around the moon. You can also see here, as the terminator goes by, that is the region, that is the separator between the day side and the night side of the moon. You can see here some of the craters that are being named. And so actually the south pole of the moon is at the top here, where the famous Shackleton crater is that we'll be seeing a little later on. I also want to point out exactly where the Apollo missions landed on the moon, as this is an incredibly different location than the lunar South Pole, and we need to carefully consider the environment that astronauts and equipment are going to be experiencing at the lunar South Pole when they land there, so that we can actually study here on Earth all of those risks and put in place technologies and procedures now that are going to enable the crew to carry out the missions that they are going to have, which is to establish a sustainable presence on the surface of the moon, which not only includes crews cycling back and forth there, but also using the moon as a natural resource for some of the consumables that are going to be needed by that crew. And we'll talk a little bit about that also. But there is a very good reason why the Apollo missions landed all in this clustered area. The first one is this is energetically efficient to land near the equator of an object. And this is one reason why the south of Texas and central Florida is an excellent place to be launching satellites and human crews into low Earth orbit and beyond, because you have the natural rotation of the Earth to give you a bit more angular momentum than you would normally have if you were at higher latitudes. It gives you almost 1,000 miles an hour of already rotational speed just simply by moving closer to the equator. And then the same is true when you get to the moon. You launch from an equatorial orbit on Earth. That means your transfer orbit towards the moon is also in the equatorial plane. And so when you arrive at the moon, the Apollo missions, they actually landed near the equatorial regions of the moon simply due to it requiring less energy. They also landed on the near side of the moon because you get direct line of communications to Earth at all times, because the Earth is always in that same position on the sky. So you need to point your antennas in one direction when you're on the moon in order to speak to some people on the Earth. And so this is the equatorial region of the moon. And you can see that actually in this region, there are lots of mare. These are the dark regions here that are essentially liquidized impact basins as a result of major impacts on the lunar surface throughout its history, particularly around about 3.5 billion years ago, which is when the Earth-Moon system was experiencing a era known as heavy bombardment, which is when there were still large fragments of the solar system left over colliding with each other. And technically, they weren't planets at this point. Earth wasn't a planet yet because it had not yet cleared out its orbit of significant debris. Anyway, you can see that these areas are relatively flat, and they are, of course, geographically interesting. But if you look towards the lunar pole, you can see that there are very few flat regions and a heavily cratered region up there. So we have the challenge of actually changing the inclination of the orbiters as they approach and come into land at the lunar south pole. And we see a very different geographical environment there, dominated by large craters and steep slopes. And we'll also see some of the other challenges that the crew are going to face in the coming slides. Now, what we have learned from Apollo, and we can see here Apollo 11, 12, 14, 15, 16, and 17, is that as you develop your capabilities in space, you learn more, you find out some of the risks that you were not aware of before you went there, and you develop your technologies to the point where you go from simply demonstrating your technologies to using those technologies to actually carry out scientific study of the surface. So we have the iconic image of Buzz Aldrin here on the surface in Apollo 11. Apollo 12, which we will look at in more detail in a moment, that was a precision landing demonstration, and Apollo 12 actually landed within 130 meters of the Surveyor 3 spacecraft, which was one of the precursor spacecrafts to land on the moon, in preparation for Apollo, to essentially determine that it was possible to land on the surface of the moon without spacecraft sinking into what was thought to be a very powdery surface, and is a very powdery surface. As the technologies developed, we went from having one EVA of a few hours to 2 EVAs of a few hours. And then those EVAs actually developed to the point where there was the lunar rovers, of course. And then, of course, with Apollo 17, the astronaut pictured here is the only scientist to have ever visited the surface of the moon. This is astronaut Jack Schmitt, who is a geologist. But we can see here the technological development of the exploration of the lunar surface in the equatorial regions. And this is something similar that is going to happen to the Artemis missions as they develop. So not only do we have crew waiting on the pad at Kennedy right now, we also have stacked in High Bay 3 of the Vehicle Assembly Building, the SLS launch system, and Orion is stacked on top of that right now. And some of us have been lucky enough to get in there to see that spacecraft, which they should be rolling out for a wet test soon. So there'll be some more very wonderful opportunities for people to view that spacecraft in the lead up to the Artemis missions. All right, so the two significant risks that we're going to discuss today are two of the risks that we are working on at the Kennedy Space Center. And these are to do with the dust, also known as the regolith environment of the lunar surface, and also what has not yet been significantly experienced by crews on the surface of the moon, the sun angle, particularly at the lunar south pole. So we're going to start with the dust, the regolith. Now you can see here the iconic footprint on the lunar surface, and that the surface is actually covered with a distribution in sizes of particles ranging from a few centimeters down to particles that are actually a few microns in size. So that's millionths of a meter. The other thing that we're seeing here is that the footprint, unlike when you stand on a beach and leave a footprint, the footprint here of the astronaut's boot is incredibly well defined. The regolith is actually holding its shape. And because we know the geometry of the illumination from where the position of the sun was and the depth of the treads on the boot, we can actually determine the depth of this footprint simply from this photograph. And that's basically a process known as photogrammetry, determining geometry from photographs. And so it was determined that in this particular boot print sunk several inches into the lunar surface. The sun angle we're going to revisit, of course, because at the lunar south pole, you're going to be in an eternal sunrise. And the closest experience that we've had with a crew on the surface is Apollo 12. When Apollo 12 landed on the surface, the sun angle was 7.5 degrees. So the sun was 7.5 degrees above the lunar horizon. At the lunar south pole, the sun on average, or actually at best, is going to be 1.5 degrees above the lunar horizon. So it's literally going to be skirting around the horizon, dipping behind local hills and crater rims and all sorts of other geographical features. So it's going to be a heavily shadowed region at the lunar South Pole. All right, so what else do we know about regolith from the Apollo missions? Well, first, the regolith, the dusty overburden on the surface of the moon, is loose enough that when a spacecraft comes in, the descent engines of that spacecraft interact with the lunar surface and eject the regolith that is underneath where the lunar modules were landing. And we can see here during the landing videos from the window of the lunar modules that the video cameras recorded a significant drop in opacity to the lunar surface as a result of the regolith being ejected. Now, unlike on the surface of the Earth, where we've got brilliant images of SpaceX's core stages landing back on Earth, and you have the clouds that come out, unlike on Earth, where the Earth's atmosphere actually decelerates all of those dust particles into a cloud, and the particles are actually experiencing some buoyancy because the Earth's atmosphere is a fluid. Unlike on Earth, there is no atmosphere, there is no appreciable atmosphere on the moon. So these particles are all on ballistic trajectories. And so this is a significant concern. And this is something that we are working to quantify at the Kennedy Space Center, how big of a risk these particles are to other surface assets. So you can imagine in the Artemis missions that there's going to be multiple spacecraft landing at the same position. And so there's going to be, as the Artemis missions develop, more and more surface assets developing around those landing sites. And they are going to essentially be sandblasted by the craft coming in and landing on the surface. And we'll see a little bit more of that in a moment. We also know that when the spacecraft launch, the same dust is kicked up. We also know that by exploring the lunar surface just through regular activities, regular exploration activities, astronauts kicking up the dust or the rovers kicking up the dust, that dust, this regolith gets everywhere. And here's another iconic image of astronaut Gene Cernan. And you can see how dark and horrible this EVA suit is after returning from exploring the lunar surface. And this is actually back in the command module, back in lunar orbit. And this is a real problem for the crew. When they take their helmets off, all of the dust, the regolith that they had been tracked on their suits is now in the cabin with them. And not only do we have all of this evidence from exploration of the lunar surface, but also from observations of the crews themselves. And it was a significant concern as this regolith is not like sand here on Earth. There's been no weathering activities on the moon that has actually smoothed out the particles. So even though it's as fine as talcum powder, it's as coarse as asbestos, the regolith on the surface. So these regolith particles were getting into the suits and preventing them from actually engaging the suits properly, and they are actually creating wear in the fabric as well. Now, we also know through interactions with the solar wind that lunar regolith is going to be potentially very interesting in terms of its dynamics, how lunar regolith moves around the surface. So the moon, having no magnetic field and no atmosphere, is directly exposed to the full strength of the solar wind. The solar wind includes photons, particles of light, and also a plasma, which is particles, baryonic matter. So in the solar wind, we have protons and electrons bombarding the lunar surface, and we also have high energy photons bombarding the lunar surface. And so on the day side of the moon, as a result of the interactions with the solar wind and the solar UV and X-rays, the day side of the moon actually gains a small positive charge. This is because the electrons and the photons interacting with the surface layer of the lunar surface actually create ionized particles on the lunar surface. And this actually sets up a small electric potential, and it is thought that lunar regolith particles can actually levitate to an altitude of a few meters on the day side of the lunar surface as a result of interactions with the solar wind. On the dark side of the moon, the night side of the moon is actually creating a barrier to the solar wind. And so behind the moon, on the dark side, there is a plasma void. It creates a wake in the solar wind. And because electrons in plasma have a lot more energy than the protons. They move faster, they're smaller. The electrons actually fill this void much more quickly than any of the other ions and charged particles. And so the dark side of the moon is actually bombarded by a significant number of electrons as the plasma void is being filled in behind the moon. And it's thought that the dark side of the moon can actually be charged up to around 400 volts. And so we have a significant potential difference from the day side and the night side of the moon. And we have charged particles that are potentially levitated above the lunar surface. And so this is an electrodynamic situation where particles can actually be moving in the near lunar surface as a result of interactions with the solar wind. We also have interactions with the meteorite flux. So micrometeorites are bombarding the surface of the moon as fast as we're seeing shooting stars entering Earth's atmosphere. And that is also kicking up the lunar regolith and actually grinding it into finer and finer particles. Now, we have observational evidence for this interaction with the solar wind, starting back with the Surveyor spacecraft in 1968. Using the cameras on Surveyor 7, it was actually seen that there was a lunar horizon glow as sunrise was approaching. The cameras on board these instruments were looking towards the lunar horizon, and they saw a glow on the horizon, much like you do here on Earth. And this glow is completely inconsistent with zodiacal light. Zodiacal light is a result of scattered light from the small particles left over in the plane of all of the planets, the ecliptic, in our own solar system that actually scatter sunlight back, but that has a particular signature. But this lunar horizon glow is actually consistent with 10 micron sized particles being levitated around about 1 to 2 meters above the lunar surface. So we have evidence for this lunar horizon glow back in the late 60s. We've also seen from astronaut sketches that they also determined that there was a lunar horizon glow. And here's some sketches from one of the Apollo missions, their handbook, so in 1972, so that would be Apollo 15 or 17 maybe, I can't remember. But these astronauts also made notes that they saw the similar horizon glow from actually several kilometers in altitude above the lunar surface. We've also revisited low lunar orbit with spacecraft, and here's an example of some Clementine observations. So Clementine was a lunar satellite. It also saw lunar horizon glow. Interestingly, in this image, the bright source here is actually Venus. But we have all of this observational evidence and a theoretical framework that heavily suggests that lunar regolith is not only going to be a problem for crew as they kick it up through their operations on the lunar surface, but it's also going to be a problem as it's levitated and moved around the lunar surface as a result of interactions with the solar wind and the meteorite flux. Now, these experiments that have been done over at the University of Colorado have actually been, these hypotheses have actually been replicated in the lab. And so over at the University of Colorado, where they have the LASP, the Laboratory for Lunar Studies, they've actually recreated conditions on the lunar surface in terms of the solar wind and also the photons coming from the sun. And they've actually put in a vacuum chamber some lunar simulants. So this is a lunar regolith simulant, and they've bombarded in the vacuum chamber this regolith simulant with the plasma and electrons that are expected in the solar wind. And they actually saw the particles jumping up as postulated from the observations. And also when bathed in UV, these particles are actually, they also skip around, and you can actually see after several minutes, approaching an hour, that a originally rough surface actually gets smoothed out through interaction with UV photons. And then here's just a cool graphic from the Goddard Space Flight Center, where they have basically a center for space visualization, or a space visualization center, of what a highly exaggerated look at what a micrometeorite bombardment of the surface would look like. So we also have more evidence from orbiting spacecraft about interactions with the lunar regolith as a result of micrometeorites. And here we have a graphical illustration of the LADDI experiment. So this experiment was sent out to explore the lunar environment in terms of the orbital environment, and on board of that was a experiment called LDEX, and its job was to basically serve as a sensor for every time the spacecraft was impacted by particles. And so what we have here is a buildup of density of particles in low lunar orbit, and they measured that density peaking above the day-night terminator on the moon, and actually that the density actually increases the closer you get to the lunar surface. So this is consistent with there being a strong potential gradient across the day-night side, actually levitating particles and moving them around from the day to the night side of the lunar surface. But they also noticed a peak in the density of objects hitting the LDEX experiment that coincided with known meteor showers. So you can see here, for example, the Geminids that we'll be experiencing in late December. They noticed a peak in the impact rate on the LDEX experiment, consistent with an increase in the density of regolith particles in the lunar exosphere, coinciding with the arrival of more micrometeorite bombardments. Now, there is another side to lunar regolith. It's not just posing a risk to lunar exploration. It is also posing as a resource. And so the other side of lunar regolith, aside from trying to understand and mitigate the risks that it poses to the crewed exploration of the lunar surface, it is also a resource because we have strong evidence that is consistent with the presence of water ice in very broad regions on the lunar surface. So there was an experiment called LCROSS, which was a spacecraft that was purposefully impacted into the lunar surface in order to puff up particles from the lunar surface that they could then be analyzed whilst they are puffed up from the lunar surface. And that experiment, actually reported here by these authors, saw evidence consistent with there being about a 10% by volume, 5% by mass, actual water constituent in the ejector from the LCROSS impactor. Now, we also then, based on these measurements, that allows us to try and determine how that kind of 5% by mass could be distributed in the regolith itself. And there are two ways that this could happen. One, the water ice could actually be existing in pores, so essentially holes in the regolith itself, in this kind of mottled distribution, but it could also be potentially distributed along grain boundaries in what we call interstitial ice. So this is where the regolith particles themselves can be coated in a thin layer of water ice. And both of these spatial distributions of water ice on the moon are consistent with the observations that we had from the LCROSS impactor. Now, it's also thought that these ice deposits will actually exist more in regions that are very cold or in permanent shadows. And so this is permanently shadowed regions are very common towards the poles because of the low sun angle. So there's a lot of shadows around there, but water can also be distributed in bulk deposits that are subsurface as well. And so one important instrument to take to the lunar surface is what's known as a ground penetrating radar, which will actually be able to use radar signals to determine changes in density below the lunar surface that could be consistent with the presence of water ice. So we have the potential for water to be distributed on the grain scale in and amongst the regolith itself, the regolith particles itself, higher densities in the cratered regions where you have large areas of permanently shadowed regions, and then also in the subsurface regions itself. So we have the potential for water ice to be present on the lunar surface in bulk quantities enough for it to be considered a resource that is useful to be mined. So going in even further on the science that has been done to support the postulate of there being water ice, we've actually had significant imaging now from high resolution cameras deployed directly on the lunar surface and in very low lunar orbit. And we can see here that there are cold traps on multiple scales across the lunar surface, ranging from the centimeter scale, from these small rocks creating these tiny shadows, to tens of centimeters where we have small crater regions, up to kilometers in regions. So we have a range of scales potentially for the distribution of water ice. Now, the water ice is important not just for the obvious things that human needs to drink, remain hydrated in order to survive, but water, of course, is made from hydrogen and oxygen. And hydrogen and oxygen is actually the core components of liquid rocket fuel. So when you look at the big orange container, the external fuel tank on the shuttle, and when you look at the Space Launch System orange fuel tank, that fuel tank is in two parts. One is filled with liquid hydrogen, and one is filled with liquid oxygen, and we can actually get liquid hydrogen and we can actually get hydrogen and oxygen, the constituents of liquid rocket fuel, through the electrolysis process that we all have done in our introductory chemistry labs. And so the importance for water being present on the lunar surface is that if we can come up with technologies to mine the water that is already present on the lunar surface, that is less mass than we have to launch from the surface of the moon, the surface of the Earth to the surface of the moon in order for there to be sustained exploration of the lunar surface. Now, when you look at a stacked rocket that's going to low Earth orbit, 90% of that rocket is fuel. And so only 10% of the mass of that rocket actually makes it into low Earth orbit. When you are launching a rocket from the surface of the Earth that's going to go to the lunar surface, only 2 to 3% of the mass of that rocket actually gets to the surface of the moon. So every kilogram that you can save by processing materials on the lunar surface is a kilogram you do not have to launch from the surface of the Earth. And it allows you to increase your redundancies in some of your systems to make it safer to travel. And it also enables you to take other things that will enable you to advance your habitat, or perhaps take hydroponic systems there to start growing food on the lunar surface. So actually, by being able to determine the spatial distribution of water ice on the moon, this is incredibly important for the sustained human exploration of the lunar surface. Now, we've talked about the regolith. I now want to move on to talk about the sun and what issues the sun is actually going to create for operations on the lunar surface. So here we return to the iconic footprint from Apollo 11, seeing the rigidity of the fine particles on the lunar surface because of how coarse they are. They like to stick together. But the sun angle was important here because it allowed us to determine, using photogrammetry, the actual geometric features that we're seeing on the lunar surface. However, on the lunar surface, because there is no atmosphere to scatter the light like we have here on Earth. So during the day, you see the blue scattering of the sunlight really well. And actually, those of you that have done some significant photometry at night will also see that the Earth's atmosphere is still scattering blue light at night as well. But here you can see an astronaut, I believe this is Neil Armstrong during Apollo 11, taking an image of the lunar surface with the sun at his back. And what's happening is, because there's no scattering of the sunlight, the shadow that he creates is incredibly dark. And the lunar surface is incredibly bright, very near to the shadow. Now, it's not a perfect shadow because the sun actually subtends ½ a degree on the sky. So there is a little bit of a penumbral effect there. But what you're noticing likely is this halo around the helmet of the astronaut. So what's happening here is what's known as zero phase backscatter. It is a combination of diffraction of light around the solid object of the astronaut itself, and also as a result of the geometry between the imaging device, the sun, and the actual construction of the regolith on the lunar surface itself. So the lunar surface can actually scatter sunlight as well because it's very coarse, and so it scatters it in very many directions. So this creates a high contrast issue when trying to carry out lunar operations. And you can see here that in this camera image, you can barely make out any surface features in the direction of travel in the direct sunlight, and you can't see any surface features in the direction of travel for this astronaut because it's simply too dark. Now, Apollo 12 is where we really see the sun angle creating significant issues. As I said before, when Apollo 12 first landed, during the first EVA, the sun angle's 7.5 degrees. And so here is an example of the lengths of shadows that the crew of Apollo 12 experienced during EVA-1. Here you can see the length of shadow of the astronaut, and you can actually see the perspective in that shadow as well. And here you can see the shadow of the lunar module. And I think you can see also one of the either the ladder or the legs of the lunar module here. Now, the original estimate of the length of this shadow was completely wrong because of the sun angle. This shadow is actually casting a shadow from the lunar landing module of 135 meters here. And so you completely misjudge scale on the lunar surface when you are at low sun angles because of this contrast ratio problem and the actual lengths of shadows that you see on the lunar surface. Now, this creates a significant operational risk because if you cannot judge distance accurately, you are not going to be able to determine distance to potentially to hazards on the surface that you need to avoid. Now, I also that Apollo 12, building up of the technology from the Apollo missions, was the first mission to do a precision landing, and it landed on the opposite side of a crater that's now named Surveyor Crater at a range of 135 meters from Surveyor. So this is the image that they first took of Surveyor, and you can actually see the Surveyor 3 spacecraft there on the lunar surface on the side of a crater wall. Now, the astronauts seeing this completely misjudged the steepness of this crater wall. They thought it was around 35 to 40 degrees in steep, which means they would not be able to safely traverse over to this spacecraft to inspect it. However, once the sun angle got higher during their second EVA, it got to an angle of 12.5 degrees. They actually found that Surveyor 3 was in full illumination, and the slope of the crater was only about 14 or 15 degrees, which they could quite easily traverse. And so here you can see the effect that contrast ratio and shadowing has on the ability for not only imaging devices like this camera, but also the astronauts themselves to completely misjudge the elevation changes on the lunar surface. So that is a huge risk that we need to work towards. Now, here is what the lunar lighting environment is actually like at the lunar South Pole. So here we have the iconic Shackleton crater. Across it is 13 miles or 12 kilometers if you prefer metric. The actual lunar South Pole is where the laser pointer is. That is the point around which the rotational axis of the moon actually operates. And you can see during 27.3 days, the position of the sun is creating these shadows on the lunar surface. However, it is also creating regions that are in almost near permanent sunlight. And so this is an incredibly powerful video for determining the precise locations that crews should aim to land at if they want to have illumination from the sun to power their solar devices, right? Their solar panels. It's good to have the sun all the time, but also regions of scientific interest and operational interest that are in near permanent or permanently shadowed regions. And so you can see here, this is why the lunar South Pole is so interesting, because there are plenty of regions that are in permanent shadow, but there are also plenty of regions that are in near permanent sunlight. And so one of the most interesting regions here is called the connecting ridge. and it's actually a relatively flat area near the lunar south pole, where there is near permanent sunlight, but also a large number of permanently shadowed regions. So we can actually zoom in on the Shackleton crater and look at the actual elevation and illumination as a result of the elevation of the lunar surface, how high the lunar surface is with respect to the surrounding topography. And so here what we're seeing is a representation of the lunar surface in terms of the percent time it spends in sunlight. So the darkest blue areas means that there is no sunlight that goes into these regions. And then the very deep red is where you have near permanent sunlight. And so you can see here around the rim of Shackleton crater, and then this connecting ridge down to the 8:30, almost 9 o'clock position. You can see here why this region of the lunar surface is so interesting. So we can zoom in on the ridge of the Shackleton crater. X marks the lunar south pole here. And then we're going to zoom in on these three regions. So the two connecting ridge regions and then the rim region here. And zooming in on those, we're now looking at percent sunlight compared to the position of permanent shadow. And so these are why these regions are so interesting for the crewed exploration of the lunar surface, because you have permanent sunlight near permanent shadows. So the permanent sunlight is excellent for powering your solar devices, and the permanent shadow is excellent for mining your water ice. You do not have to travel far between your base of operations and the area where you're actually going to carry out mining and processing activities. So this is why we're so interested in the lunar south pole. Now, in terms of developing instrumentation at the Kennedy Space Center, we're working on two apparatus that are actually designed to reduce operational risk at the lunar surface. The first is an instrument we're developing called LEIA, and that is the Lunar Environment Imaging Apparatus. And this builds on some work that I did a few years ago on the International Space Station, developing an advanced sensor that we'll look at in a minute. And then we're also developing the Advanced Lunar Array for Regolith Monitoring, which we call ALARM. An ALARM is an array of detectors that will actually be at the location where the regolith is going to re-impact the lunar surface after it has been accelerated from the interactions with the descent engines of the landing modules. And so that is going to tell us about the risk that is going to be experienced by surface assets on the lunar surface, but it's also going to tell us about the intrinsic dust concentration in the lunar exosphere as well, because the alarm array is going to be able to determine the regolith dynamics during a time when there isn't a lunar lander. So it's going to be able to see if there is an increase in particles falling on these nodes of the array during a period of micrometeorite bombardment, or if there's an increase in regolith as the terminator swings by. So in 2017, I was lucky enough to be the principal investigator of a successful International Space Station demonstration flight for an imaging technology called a charge injection device. So we launched this payload on SpaceX 10, and we went up to this payload went up to the space station. The astronauts installed it on the robotic arm, and it was deployed on the outside of the International Space Station for 8 months, where the camera actually went through a series of tests successfully. And we actually had that payload return to Earth. And here's a picture I took once the payload actually returned to Earth as well. So here you can see this is the same hardware. We actually had it returned to Earth post-mission so that we could carry out some analyses on it. And we're glad we did, because we've got some significant thermal damage to the outside of the payload here, which is nothing to do with our payload. It was something to do with a payload that we weren't told about that was also deployed at the same time. So we don't know how it got damaged, but it does explain some of the thermal problems that we are experiencing during deployment of this instrument on the International Space Station. And due to the heavy, heavy government regulations of imaging devices on the International Space Station looking down at the Earth for, I think, what's obvious reasons, we had no optics inside this camera, so we actually came up with a very boring test pattern that enabled us to go through all of the capabilities of this camera that includes the ability to look between regions of high contrast. So this is why we're interested in developing this into layer for actual use on the lunar surface at the lunar South Pole, where we have those high contrast issues between the backscattered light and the deep shadowed regions. All right, so this is my last slide. We'll leave some time for some questions. So I just want to reiterate that the lunar South Pole region is scientifically and operationally interesting because it has the high likelihood that we can use that region due to the large number of shadows to determine the presence of and use the water ice that is present there, but also because we have the sun angle creating the illumination conditions that are conducive for near continual solar power. But the regolith itself can cause operational issues, particularly when the spacecraft is landing and when astronauts are kicking it around on the lunar surface. And we also need to make sure that we reduce the risk associated with high contrast ratios on the lunar surface, because it can confuse astronauts in terms of the operations, particularly when trying to determine the features on the lunar surface itself, the actual topography. So I'll leave this slide up and I look forward to hearing any of the questions that you may have. And thank you for your attention.
Thank you. That was a great talk.
Thanks very much. Yeah.
So do we have any lunar dust questions? I'm surprised. This is usually a very chatty group.
Well, I'm seeing one question from John, and John asks, how does this help with our Mars exploration? Okay, that's a great question. So the mantra at NASA is that we are carrying out lunar exploration with a Mars forward attitude. So all of the operational procedures that we develop on the lunar surface are operational procedures that can then be adapted to sustained exploration of the Martian surface, particularly in terms of dealing with the dust, and particularly in terms of developing the technology necessary to use resources found in situ on the surfaces of these planetary bodies. So being able to find and process water ice on the surface of the moon is going to develop the technologies and techniques that we need to find and process water on the surface of Mars as well. And so all of the things that we are going to be learning from the exploration of the lunar South Pole are going to be directly applicable to the skills that we need in order to safely explore the Martian surface as well. So think Mars forward. Everything that we're learning on the surface of the moon is more things that will enable us to safely explore the Martian surface in the coming decades.
Always set your tent up in the backyard before you head into the mountains, right?
Quite, yes. Well, that's the other point, is that if something goes wrong on the moon, it's only a 3-day return trip.
Or a 3-day rescue trip.
Yes, precisely, yeah.
We did have another one. Frank Kane wants to know what can be done to mitigate the impact of dust at the poles. Do you see this as a potential showstopper if not addressed?
Yeah, Frank, that's a great question. So at the Kennedy Space Center, there is significant effort going into dust mitigation. And so this is developing technologies that enable us to actually control where dust is actually present. So we want to be able to control the dust, because not only can it get in the EVA suits, it can also get in the mechanical articulating joints. It can get into the airlock mechanisms. It can get into any coupling mechanisms. So for example, if you're trying to hook up a power cable or a fuel line, it can actually coat the surfaces of your solar panels, reducing their efficiency. And it can coat the surfaces of radiators as well, which will reduce your efficiency to control the thermal environment inside the spacecraft. And then it could also coat itself to the exterior of spacecraft so that when those spacecraft actually on their ascent back up to the lunar gateway could be taking with them more lunar regolith attached to the surface as well. So because lunar regolith carries charge, we can actually use electrodynamics to control the spatial distribution of lunar regolith itself. And there is a technology called the dust, what's it called? It's an electrostatic dust shield. That's what it's called, the electrostatic dust shield. And the technology is a perspex or a plastic that has got electrodes embedded in it. And when a current is passed through those electrodes, it creates a magnetic field on the surface of that. And the charged particles move along those electric field lines, and you can actually generate a surface distribution that actually clears away the regolith from the center of that particular object. So this has been developed particularly for the visors, particularly for windows, and there's actually some technology demonstrations that are going to be done on the upcoming commercial landers, commercial lunar providers that are going to be landing small spacecraft on the surface of the moon to actually carry out smaller technology developments. So yes, we can actually address lunar regolith, some of the problems that it creates, but we're not going to completely mitigate it. And so we have to be aware of it, be conscious of it, and develop processes and procedures that are going to minimize the risk that it poses. Great question, Frank. Thank you.
Speaking of electrical charge, another member asks, the slide showing the solar wind and interaction with both sides of the moon showed plus and minus. Would this be something that can be utilized for generating resources?
So the if I interpret that correctly, it's can you use that potential difference as a resource? That's a great question. I'm just trying to bring up the slide.
Is the moon a giant battery?
Well, yeah, right. So it's this slide. Okay. So the strongest potential difference is actually going to be at the terminator. And so the lunar south pole is permanently near the terminator. And so the actual environment, the dust environment, if there is a significant amount of lofted regolith as a result of the electrodynamic interaction with the sun, it could actually be, you could actually have dust swirling around at the lunar south pole and the north pole for that matter. So I haven't come across anyone attempting to use the potential difference between the day side and the night side of the moon as a resource. It's about a 400 volt potential difference. But there are some interesting papers that you can look up about how as you move around on the lunar surface, you actually build up charge and essentially become your own capacitor. And so this is actually a worry for astronauts that spend a significant amount of time scuffing around on the lunar surface. They actually build up charge. And so there could be potentially be a static discharge as they approach a sensitive electric panel, for example. And so right now, we're more concerned with what the risk is from this, but it's very forward thinking to turn a crisis into an opportunity. And I like your thinking, Jacqueline, and that's definitely something that you should be thinking about and in engaging people on. So thank you for that question. I'll take that back to the team.
I just finished a good book. I was trying to find it. I just finished a good book and I can't remember the name of it about the moon. And it discussed the fact that you can actually make solar panels with material that is on the moon, and an abundance of helium-3 on the moon for potential cleaner nuclear fuel. So the moon is our destiny, really. It's quite, it's one of my favorite things.
Absolutely, yeah.
If we don't have any other questions.
Oh, actually, we do have two more questions in the Q&A
I missed
that
them.
I missed them too. John Pinto actually pointed them out. Thank you, John.
Thanks.
So
Yes.
Elaine asks, is there a similar effect near the Earth from poles from the low angles of the sun?
Okay, so those of you that have to travel directly east or west to get from home to work or from home to college in Florida know this problem, the sun angle problem. So if you are traveling at sunrise towards the east, directly east, there are no mountains in the way, right? There may be some trees or buildings, but about 20 minutes after sunrise, you'll see that the sun angle is about the same altitude as the traffic lights that you're trying to see at a junction. And so, yes, the sun angle is a problem on Earth. However, it goes away relatively quickly. If you wait 15, 20 minutes, then the Earth has rotated, so the sun angle has increased enough for it to become less and less of a problem. At the lunar south poles, you perpetually have that you have eternal sunrise. Eternal sunrise at the south pole of the moon. That would be a great title for a book. But yeah, you do have that sun angle problem here on Earth. It just goes away quite quickly. But there is an increase in traffic accidents at that time of day, not necessarily because of the sun angle, but because of the higher density of traffic as it's the commuter time. But I experienced this problem when driving over the causeways early in the morning. You get the sun angle right there, creating a high contrast issue for you, particularly if you have a dirty windscreen. Great question, though. Yeah.
Hate that time of year.
Yeah.
And I found my book, Moonrush, the new space race by Leonard David. It's actually quite readable. I could hardly stop reading it. Put it down. Maybe I'll do a book review next month for one of our mini programs.
Or maybe we could get him to speak. I'm actually friends with him. He lives.
Oh, you know him?
Yeah, he's friends with Zubrin.
All right,
Dr. Robert Zubrin. And
all right. Trisha,
so
that's your new assignment then. That's your new assignment.
And it looks like our last question from Todd Parker is, how will solar panels be deployed? They would have to be mounted vertically, but with a 360-degree rotation of the sun. I imagine that tracking might mean that panels would block the light to other panels at certain times.
Right. So, yeah, good question again. And for the design of those panels, you can see that you actually get more and more sunlight the higher you put those panels. So going back to this potential design for a lunar lander, you can see that the panels are quite purposefully very high up. That gets them above the local shadows. You also may see some spacecraft that have got solar panels wrapped all the way around them as well. And so, yes, you can do two things. You can actually just have more panels that actually cover all the azimuths around your spacecraft. And there's one particular spacecraft that has that design, solar panels wrapped around a high part of that spacecraft. And of course, you can also use a little bit of power to track the sun with these solar panels as well, or the sun is moving so slowly on the sky that you can actually have an astronaut, just move them slightly. So there's plenty of design methods to ensure that the solar panels that will be deployed on the lunar surface are going to be tracking the sun during its 27.3 day trek around the lunar horizon.
You're good. Finally, I don't know if we plugged it or not, but you have a book, Astronomy Saves the World. There is a link that Trisha posted in the chat box on Amazon, or Frank I can't tell who posted it, but somebody did. Thank you, whoever posted that. So if you enjoyed that, I'm sure you will enjoy his book as well. Okay. So is there any other questions that I'm missing? I don't see anything. Trisha just posted another link to make it easier to find.
Looks like we have one from Yamil Gassel. Sharifa's.
Okay.
So the question is, how will temperature differences at the lunar poles versus lunar equator affect design of spacesuit life support systems?
Well, that's another good reason for visiting the lunar south pole, is that the thermal variance, the change in temperatures, are much less significant at the lunar South Pole and the North Pole than they are at the equator. And this is because the sun angle is almost constant there. So of course, the reason we have changes in temperature on the Earth are to do with the altitude of the sun, right? It's the cosine relationship. So the higher the sun is on the sky, the more flux is falling within 1 square meter. So if you have the sun directly overhead, as you do at various times when you're in the tropics, that is where you get the highest temperatures. And when the sun is lowest on the sky, this is when you get the lower temperatures. And of course, the Earth has that effect of its tilt that creates the seasons in the relative seasons in the northern and southern hemisphere as a result of that. The sun simply gets higher on the sky, depending on which part of the orbit the Earth is on. So actually, because the sun is actually almost constant, at an almost constant height at the lunar South Pole, because the moon is only inclined at 1.5 degrees rather than 23.5 degrees like the Earth, the actual temperature variations experienced at the lunar South Pole are much less severe than the temperature variations that you would experience between night and day if you're in the equatorial regions. So thermal control is still a major component of design, but the actual swing in temperature at the lunar South Pole is a lot less significant. Rather than being several hundred degrees, I think it's several tens of degrees. Yeah.
And it looks like Mauricio has a question here. How fast are the velocities of the lunar dust accelerated by the solar particles? Dangerously fast?
No, we don't actually know. We think that through indirect observations, simulations, and the like, that dust is actually being levitated. But that process is likely a very gentle process rather than a rapid exchange of momentum, like what you would get with the impact from the meteorites. The impact from the meteorites are actually creating particles that can get to several hundred kilometers in altitude. So these particles would actually be leaving the surface at 1,000 meters per second, a kilometer per second or so, to get to those types of altitudes. But bear in mind that these particles are very tiny. They are, on average, the particle size of the lunar regolith is actually about 70 microns. So these are tiny, tiny particles, but they could actually be traveling at a kilometer or 2 kilometers per second as a result of interactions with meteorites. We don't really know how fast the particles go after they interact with the descent engines. It could be anywhere from a few hundred meters per second to a few thousand meters per second. This is actually one thing that we're trying to work out at the agency right now. But bear in mind that there is also a background of particles from the meteorites as the Earth passes through the tails of comets. We get those meteor showers, and those particle speeds can be tens of kilometers per hour simply because of the orbital motion of the Earth through that tail. So actually the particle velocities of as a result of interactions with human landing systems, as a result of interactions with the solar wind and the micrometeorite flux, are actually going to be slower than the actual impacts from the micrometeorites themselves. So while it is a worry about what that regolith is doing, of more worry is actually the amount of momentum that is coming in from those lunar particles. And this is one reason why the spacecraft designed with a particular tolerance for being hit, and why you may see some designs of lunar habitats that actually get lunar regolith and kind of pile it over, create an overburden on habitats. So that creates a radiation barrier and also protection from micrometeorites. Yeah.
Okay.
Yeah, and I think that's it for questions.
Great. Thank you very much for your time tonight. Great presentation.
Thanks very much.
Great presentation. And I love it when we get back to lunar talks.
All right.
So on with our mini programs then tonight. Derek Demeter is going to, he's got 2 mini programs. He's going to show us some member photos. We've had a couple of very clear nights. I think the number of clear nights is finally statistically beginning to improve. And I know a lot of members were out taking pictures. So hopefully you sent them in to Derek. Every month we like to showcase those. And then Derek is going to give us a night sky tour, the last one via Zoom, and then we'll get back to the planetarium. It's one of my favorite things for us to do when we're in the planetarium. Derek, are you ready to roll?
Let's do it. All right. So
Do it.
again, for everybody who's joining in new, when we do our showcase of astrophotographs, if you are interested, I will give you permission to talk. And if you see one of your photos, we'd love to hear more about the technical details and a little bit more of the information about your photos. So what we're going to do here is we're going to start off. We actually have quite a nice collection this month of astrophotos. So as Richard mentioned a minute ago here, it's been clear, the weather's been nicer, less bugs. Hopefully this trend will continue on through the winter months, especially once now we're done with daylight saving time. It's getting darker earlier. We're entering the winter time. So it's, we'll have more darkness, more astronomy. So hopefully we'll see more as time goes on. All right. So our first image, let's see. For some reason, there we go. Let's try this again. For some reason, it kicked me off. So let's try this one more time. All right. The first image that we have is from Mauricio Moreno. Mauricio, you're actually already a co-host. So if you want to go ahead and unmute yourself to chat a little bit about this one.
Hey, can you hear me okay?
I can hear you good.
All right. So, yeah, a few weeks ago, we did a little family trip down to the Keys and we stayed in Isla Morada. And the first night, it was a crazy, crazy thunderstorm. I mean, we're talking like multiple lightning strikes per second over the ocean. It was a crazy rainstorm coming in. And I thought the whole weekend was going to be ruined. But I managed to get these really nice pictures off the ocean from the storm, and the next night turned out to be really clear actually. And I brought my little telescope with us and did some family observing, and I managed to get this picture from the hotel. And it just really makes you appreciate that in the Keys, because they're so small, even when you have local lights from city or from the hotels and restaurants, just above there, the ambient light pollution is pretty low. So you can still get photos like these and get some great observing in.
Yes, and of course you looks like you're facing towards the northeast. You got the Pleiades on the bottom there and Perseus, and we'll go through a little bit more of that later on with my night sky tour. But that's a great shot, Mauricio.
Thank you. And actually, for this one, I actually took a page out of your book, Derek, and I tried doing. It's about 16 exposures for the sky, blended with actually 3 exposures for the ground, kind of in an high dynamic range.
Very nice.
Yeah, so I actually I was able to do a little stacking with that.
There you go. Yeah, well, definitely. That's definitely a great technique, especially if you don't have a sky tracker. And that's definitely something we could provide later down the road as far as a program on how to do that. It's actually a really effective technique, and it came out really great. All right. This next image comes from Andy. I believe he is here. Yes. So Andy, he actually, what I found really interesting about this photograph is that this is not from a very fancy schmancy camera. In fact, it was actually taken with his phone. Andy, would you mind telling us a little bit about this?
Yeah, I was actually had the telescope out, and I just set my Pixel phone up on a tripod and used the built-in astrophotography mode. It was actually quite simple.
There you go. So again, you could take some really great shots by just just using something that you probably use on a daily basis. And actually, what's really cool, Andy did bring this up, and
I was going to say, I see 2 galaxies in this photo.
yes, one thing that Andy did bring up that was interesting and when he submitted this photo was you can actually see the Andromeda galaxy on the far right hand side. So you can use a basic camera on your phone and capture another, well, actually not only one galaxy or Milky Way, but another galaxy, the Andromeda. So again, things are improving dramatically with astrophotography. So, all right, our next image comes from Richard Wright. Clearly, you know that this is from Richard Wright because of his signature down the bottom there. But Richard, what do we have here?
Thank you. Actually, I didn't mean to send you the one with the with the watermark, but this is the moon. I spent the weekend in St. Augustine the weekend before Halloween. And in fact, I had a near miss with another CFAS member. Sharife was up there the night before me taking pictures in the same place. But I used, astronomy software to figure out where the moon was going to come up behind the old fort. And I set up, and I had a 300 millimeter lens on a tripod with a 1.4 tele extender. And I took this, it's actually two photos that were about 4 or 5 seconds apart. I had to refocus on the moon, and the moon was very, very bright, even compared to the fort. Fort has a lot of spotlights on it, and downtown St. Augustine, excuse me, is very bright. But it's a composite. One is about 3 or 4 seconds, and the other one was about 100th of a second on the moon. And I kind of like the red clouds there. It's right over Matanzas Bay, which means Slaughter Bay. And I'll leave it to you on your next field trip to St. Augustine to investigate and find out why it's called Slaughter Bay. But it was very appropriate for Halloween, I thought. I was also swamped literally by walking ghost tours. It was a Saturday night, and it was quite the hopping place downtown.
Now the question: Did you see any ghosts, Richard, when you?
I did
were out
not.
there? No,
I did not. I did.
that's a bummer.
We did go on a ghost tour. It's really funny. They have photographs of ghosts, and I'm not saying ghosts are real or not, but I know a lot of those photographs were out of focus bugs when the flash went off, and it's like, it's some people have never ever taken a photo at night before apparently, and think all sorts of things are ghosts. Anyway,
Yes.
I'm sorry.
No, it's all good. All right. Well, thank you, Richard. Our next image comes from John Pinto. Actually, he has a series of images that he submitted. So this is his first image that he submitted. So John, would you be able to share us some information about this photo?
Sure. Actually, I was wondering, Derek, if you have all of them, you might as well just go one right after the other, and I'll talk about the whole series.
Yes, I think I have all three, but I know I have at least two. One was like labeled. Yeah, this is another, I think. Is that all you sent? Because that's all I believe I got from you.
Yeah, there's three. There were three.
Okay.
But anyway, as everyone hopefully saw, the moon visiting our planets the last couple of nights, we had some really nice clear nights. I decided to get outside with my ancient iPhone 6S Plus and just saw what I could do with it. Handheld, not on a tripod. And I thought they came out pretty nice to give you a sense of just what it looks like to go outside and be a stargazer without a telescope. And it was beautiful. If anybody was out there, I'm sure you probably agree. And unfortunately, it's cloudy tonight, but I'm sure the moon would be just a little below Saturn tonight. So
Yes.
if you get out there.
Oh,
There's the other one. Yep, that was the other one. Yep. So that was last night, where the moon was starting to get close to Jupiter and Saturn, and tonight the moon will probably just under Saturn tonight.
yes. And if any of you missed the moon in Venus conjunction the other couple of days ago, there is going to be another moon and Venus conjunction on December 6th. It's actually going to be a few degrees closer than the one this past one. So hopefully we'll have clear skies for that, and you'll be able to go out and take some photos as well. So fantastic. Now, the next image comes from Fritz. I don't know if Fritz is here tonight. He is. Yes. Okay. So Fritz, can you tell us about this planetary nebula that you photographed?
All right. Yep. So this is M76, the Little Dumbbell Nebula. Definitely proved to be a little more challenging than the Big Brother. So this is imaged in bicolor using oxygen 3, hydrogen alpha, both at 6 nanometer using my RC10 telescope at the native focal length of 2000 millimeters. So this is at f8, just with a field flattener. And then overall, this guy is about 18 hours of data using 10-minute subframes for both oxygen, hydrogen, and then just added in, like I usually do with bicolor, just RGB stars to kind of get that natural look of the stars, but, get the cool bicolor nebula.
All right. Yes. No, it came out great. And again, this is the nice thing about narrowband imaging is you can create some really great images, even under skies that are not ideal. So quite fantastic work there, Fritz.
Thank you.
All right. Our next image. There we go. Our next image, actually, the next three images are quite the heart because they're all parts of the Heart Nebula, but they're all in different aspects, which I really love about astrophotography is that you can take an image of the same object, but create a composition that is completely different. And I believe this one is from John Starr. So John, if you don't mind sharing a little bit about this image.
Sure. Thanks, Derek. Good evening, everyone. So really enjoyed sort of having a handful of clear nights. This is Melat 15, which is an emission nebula with a star cluster in the center of the Heart Nebula in the constellation Cassiopeia. I took this from my backyard in Winter Park with narrowband filters with a show palette. And this I took this with an Esprit 120, which I ordered back in March, and it had just arrived. So this is one of my first images with that. So I'm kind of pleased with how it came out. This is a bunch of 4-minute sub-exposures and a little over 17 hours or so total integration time. I think that I sort of got lucky in that I had to shoot once this sort of cleared my neighbor's tree. So it was quite high in the sky. And so I think the image is probably better for it. So, but anyway, yeah, so I'm kind of pleased with how it sort of came out.
Yes, and again, as John said, Winter Park. So you don't think of Winter Park being a very ideal location for astrophotography, but again, using this technique of narrowband imaging, using specific wavelengths of the visible spectrum, we're able to actually get some really awesome photos. And the next one comes from Frank Kane, and Frank Kane again provided his own insight or his view of what he wanted from this location. So Frank, tell us about this image.
Yeah, same target as John's, and that's an awesome image, John. Like, well done. This is like not as much exposure time, so not quite as much detail. About 10 hours on this one. This is from my backyard in Merritt Island, which is also, somewhat light polluted, Bortle 5, I think it is, but again, through the magic of narrowband filters, we're able to capture some of that detail in Melat 15, the heart of the Heart Nebula, if you will. Bunch of hot blue stars here that have blown out all the gas around it and left a few tendrils of gas here that are really kind of pretty, I think. This is shot with a Skywatcher 190MN telescope on a Paramount MIT mount and a ZWO ASI 2600mm camera. And the actual field of view on this was actually much higher originally, but there was this big reflection in the oxygen filter that I had to get rid of and crop out. So it may feel like this is a really creative cropping, but it was driven by necessity because it turns out a spider spun a web across my telescope in the middle of the night, and that screwed up half the image. So that drove this creative decision, if you will.
Well, sometimes the best creative decisions are from accidents or from unplanned things. So I think it came out well, Frank. So we're gonna go with that.
All right. Happy accidents,
All right.
Bob Ross would
There
say.
you go. Right, exactly. Now, of course, again, we're still on the heart, but this is a much zoomed out image of the heart, and this is from Andy as well. So Andy, tell us a little bit about this image.
I took this a while ago. I kind of forget. I don't even remember where I took this one, but I mean, it's with my William Optics GT81 and also the ASI 2600, and it's with a narrowband. Lately, I've been doing a lot of SHO blended with HOO for the palette.
Yeah, I mean it's one of my favorites because I just love the color, and I just finally was able to get the adapter for my new ATEC camera. It's only took 14 months to finally get it, so I'm finally able to do narrowband imaging, and I'm excited about because I have a William Optics GTF 81 as well, and I'm very excited about setting that up and doing my own narrowband. So this photo, when I saw this, made me very, very, very excited to finally be able to get that that telescope out there and hopefully be able to do that very soon. All right, I believe this is I'm drawing. It's been a long day. I believe this is also Andy's as well, right?
Yeah, that's the Sol Nebula. And I'm pretty sure I did this one in my driveway here in Longwood a couple of weeks ago. Even right next to that giant light pole I have in my front yard, I was still able to get it with narrowband.
Again, the power of narrowband is quite phenomenal. All right, and this is also Fritz's image. So Fritz, I think I still have you where you can talk.
Yeah, so this was a fun one. This is NG C6946, the fireworks galaxy. Named that because of all the supernova activity we see there quite often. But this is, again, with the same setup, so 2000 millimeter with the RC10 at f8, so very slow system. And I've got the, what do I have, the Kodak 8300 chip still, so a little bit challenging. So this is 22 hours of data, mixed in also with some hydrogen alpha to kind of get that, you know, those pretty red magenta regions to kind of pop. And yeah, it was definitely a little bit challenging to get the color out on this guy because you're kind of imaging, if I remember right, through, you know, some dust of our galaxy. It's kind of like the same thing as, what is it, IC 342 or the hidden galaxy. I forget the name exactly. So they can make that a little bit more challenging, but certainly adds a lot of pretty stars to the background. So definitely a fun one.
Yes, but of course, the interstellar medium, as Fritz was mentioning, provides and creates a very dramaticness to it, I think, and really adds as the draw to the galaxy there. All right, Richard, you are our final two images, and I had requested from you to have it in a certain configuration, so hopefully it fits.
Thank you. Yeah, this is M33 or the Triangulum galaxy. This is about 10 hours of LRGB data, and it's from my the remote site out near Lake San Antonio, California, that I share with a couple of friends out there. It's called Skies Away Observatory, actually, and they will have peers available soon. I get no financial, recompense from that. Just a shameless plug for a friend of mine. The skies are really great. This was with an Esprit 150 refractor and a ZWO 6200 monochrome. And I did one night, I did all luminance, and the next night I did a whole bunch of RGB and then combine them. The actual field of view on that refractor and camera it's a full frame chip, is actually much bigger. The whole galaxy shows up. But I also did a creative crop just because I like the core of this galaxy. The dust lanes, I was able to kind of bring those out a bit. And I was really happy with it. And you just kind of lose that in the whole, here's a big picture with a little galaxy in the middle of it. And the seeing out there is sub arc second oftentimes. So it's a very nice high resolution image that I was happy with.
Yes, seeing is believing. Yes, of course, as you all right. And of course, our final image.
So this is another one of my images from my own backyard. A more modest image, but I only got about an hour of data. It was with a 12-inch Newtonian with a f3 reducer, and I had problems with the camera that night. And I was like, oh shoot, I only got an hour on this, and the camera, I had to fight with the data because the camera wasn't very good. There's a lot of light pollution. And it's just one of those, I'll never show anybody this picture. And then I remembered, or I kind of realized a voice inside my head said, "You just took a picture of a galaxy from your backyard. Shut up." It's really amazing that we can do this in our own backyards. I'm also a big fan. I love narrowband. Color is great, but I think that more beginners should start with monochrome. And monochrome is actually it's very easy to do galaxies. And I did a project once called Backyard Galaxies, all shot from Lake Mary. They look better than this, but they're all just with a luminance filter on a light polluted sky. But if you take enough exposures, you can get a very nice luminance image. This is black and white. It's only an hour's worth of data. And, the noise kind of looks more like, detail and contrast. So monochrome is certainly is a great way to get started in backyard astrophotography. I believe definitely easier processing wise than color as well. Thanks for coming to my TED Talk.
All right. Well, that concludes the astrophotography showcase. And again, thank you to everybody who submitted your photos, and we look forward to seeing more. And hopefully now that the planetarium is reopened again and I'm able to kind of have a little bit of more time to myself, hopefully I'll be able to do some astrophotography, and that means that hopefully we'll have clear skies. So what I'm going to do now is I'm going to switch over to Stellarium, which is the program that I used. Of course, I am very excited to have you all out again at the planetarium in January, so we can actually utilize the dome and take a look at stuff there. But until then, we have this. So of course, this is the sky that we can see right now. And of course, if the skies were clear, we would see, of course, the moon close by to both Jupiter and Saturn. They kind of almost make a triangle shape in the sky. And then just earlier in the evening, right after sunset, of course, we have the planet Venus in the sky. But of course, we're kind of losing that right now. So of course, what we're going to do is since we're kind of looking towards Jupiter and Saturn and the moon, we're going to look over to the west a little bit to the right of those objects. And we're going to look at these three stars, these three bright stars right here. This is Altair, Vega, and Deneb. And that belongs to an asterism called the Summer Triangle. So named after, of course, here it's Florida. I mean, it's actually kind of chilly comparatively, but, of course, the Summer Triangle is still fairly visible until later December. But these three stars make up the three constellations of Cygnus the Swan. We have Aquila the Eagle and Lyra the Lyre. We actually can take a look at those star lines there. So this bright star here is Deneb, as you can see, which literally translates to tail, and that belongs to Cygnus the Swan. And basically, to find Cygnus, we're going to find its tail. And then we have a couple of stars that come down from Deneb right here. And we have another group of stars that makes a crossbar. And to some people, this is called the Northern Cross. So that's another asterism that you can use to find Cygnus in the sky. And of course, to find the swan, we're going to basically look at these stars making the wings of the swan, the tail, and of course, the back, the neck, and the head. Now, this star here, Albireo, if we were to zoom in on that star, it's actually not one star, but actually a binary star system. And for some reason, it's not showing up in the program, which is kind of disappointing. I should have checked that earlier. Well, if you were to look at this in a telescope, Albireo would actually be two stars. One's a kind of goldish yellow. The other is a blue star. So great object to look at with a fairly modest telescope. You don't need a very large telescope to split those two stars. And it's a great object, especially for outreaches. People love to see those stars. And we call them the Seminole State stars because of those are the colors that we have at Seminole State College. So, every time the college president comes over to an event, we always have to talk about those stars, regardless if the stars are up in the sky. As far as deep space objects are concerned, some of the things that we can see in the sky here is right over by Deneb is a really nice area here called the Pelican and North America. Trying to get rid of that text there. The North America Nebula here. This is a great hydrogen alpha region. So again, if you're interested in doing narrowband or astrophotography, this is a great object to look at. You don't need a very large telescope to photograph this. It's actually quite a large area of the sky. So actually a very small telescope is perfect for this image. It's very bright as well, so it's a great target to get. You don't need to do a lot of exposure time. It's definitely something worth doing. Down here we have Gamma Cygnus, which is another H alpha area here. It's actually, and then over here we have, just below that, we have what's called the bubble nebula here, or one of the bubbles, I should say, or the crescent nebula. It's defined by two different names, the bubble or the crescent nebula, which is this object here. And again, great objects. And of course, one of the more famous areas, if we go from the center of Cygnus over here to the star, these stars here, especially this star right here, and then this star, and then it kind of makes a triangle. We can see right over here is the Veil complex, which is a large supernova remnant area. We have the Western Veil and Eastern Veil. Beautiful area to photograph as well. Again, you don't need a very large telescope to photograph this area. So this is a wonderful area in the sky to look at. Lots of targets, lots of objects to photograph or just view, or if you're just simply stargazing, to look at in the sky. Now, just below Deneb here, we have the star Vega, which is part of Lyra the Lyre right here. You can see these 4 stars. And in between these 2 stars here, just a little bit south of that, is another small deep space object. I guess I thought for some reason this was in the program. I thought I looked it up, but over here in this area is the ring. Oh, there it is. That's what I was looking for. All right. I knew it was in here. Just kind of in this area, there's a small planetary nebula that's very famous to look at. This is the Ring Nebula. And this is a remnant of an ancient small star about the size of our star that has undergone basically the collapse. And what's left over is a white dwarf, a dense core of carbon found in the center there that's basically releasing a ton of energy that's fluorescing the gas around it. And then the last area I want to talk about in the summer triangle is over here. We got the stars, Star Altair, which belongs to Aquila the eagle. This is the head of the eagle. We have a couple of pair of wings here, a couple of pair of wings, and the tail. Now, we're going to look at one other area because this is a mini program. I can spend an entire hour exploring this. We're going to look at another area of the sky that I want to focus on. And this is on the opposite side of the sky over here in the east. What you'll see rising up in the sky, a lot of people mistaking this to be the Little Dipper, but this is actually the Pleiades, the Seven Sisters, or if you're from Japan, Subaru. And we have actually, there's a lot more than 7 stars here. This is actually a young cluster of stars, thought to be about 100 million years old. And a great target to look at with a pair of binoculars or a small telescope, and a great target to photograph if you are new to astrophotography. So definitely try that out. And then, of course, the Pleiades is part of Taurus the bull. So here we have Taurus's head called the Hyades right here. This makes Taurus's head with the bright reddish star Aldebaran. Down here, we have one horn here, followed by another horn. And so there's Taurus the bull. And the last area I want to talk about tonight is over here in this part of the sky. And right over here, we can see this kind of zigzag shape. Looks like a W or M, Team Wario, as I call it. This is Cassiopeia, the queen. And in Cassiopeia, we have a lot of great targets. For example, just between Cassiopeia and this constellation, which is called Perseus, is the Heart and Soul Nebula. We talked about both of those tonight in the astrophotography showcase. Great area to photograph, especially if you have even a small camera lens. You can actually photograph both these areas in one exposure. So, and then again, right over here to the right of Cassiopeia is Andromeda, the princess. Actually connects to the great square of Pegasus right here, the 4 stars that make up the great square of Pegasus. And this star Alpheratz connects down to the one side of Andromeda here. And then we have a secondary side of Andromeda. We have the star here called Merak. And from this star, we go above that, we can find the Andromeda galaxy right there. Of course, Andromeda galaxy is the farthest object you can see with your naked eye, about 2.5 million light years away. And we also have M110 and M32 as well, part of this whole area. And the last area I want to talk about is another object you can look at. Just next to Andromeda is this group of stars here that make a triangle. And this is Triangulum, the triangle. And the very far star of the triangle that meets at a point just above that, right here, is the Triangulum galaxy. And this is also part of the local group of galaxies, which we're part of. And this is about 2.7 million light years away, so it's a little bit further away. And one thing that Richard forgot to mention, he posted that on his social media, but I also talk about this as well when I bring up this galaxy, is according to George Lucas, this is supposed to be where the galaxy of Star Wars takes place, in this galaxy. So who knows? Maybe there's Tatooine and Coruscant and Ahch-To and all these other places that are brought in the Star Wars universe. So who knows? Next time you look at the Triangulum galaxy, maybe you'll see the Death Star. I don't know. But that's essentially what we have in the sky this evening. So look out over in the eastern sky. We have Andromeda, Perseus. Forgot to mention over here in Perseus is just above Perseus's head here. We have a very nice cluster of stars called the double cluster of Perseus. So a great object to look at as well in this area. So hopefully you get to go out next couple of nights and look for some of these objects. And thank you so much. And I'll turn it over.
There we go. Thanks, Derek. I shared my screen and it moved everything around. I was like, where's the unmute button? Us people in our technology. All right, time for our regular mini program, A Minute on the Moon, or in this case, Another Minute on the Moon. This week, we're going to talk about the November 19th nearly total eclipse of the moon. Very early Friday, November the 19th, in the early AM hours. It's going to be an all-nighter for sure. For those of you who want to see or photograph this. There are two parts to the Earth's shadow. It's divided into two areas. The outer fuzzy part of the shadow is called the penumbra, and the inner area is called the umbra. By the way, these are not astronomical terms or unique to the Earth's shadow. These are standard. All shadows have these features. And this month's eclipse is just a tiny bit of the moon. Is going to remain outside of the umbra, 2.6% for those keeping score. So there'll be a little bright lip that shows up at the moment of totality at 9:03 Universal Time. Since we are not living in, well, let's just say, how about some Orlando times? So about 1 a.m. is when it's going to start that Friday morning. So take the day off from work or get yourself a lot of coffee that night. Maximum eclipse is at 4:02 a.m. So again, this is going to be a middle of the night sort of thing. So this is for the night owls in the group. Here's some photos from an eclipse about 10 years ago that I took just to give you some ideas. When the moon is first enters the penumbra, it's it just kind of darkens a little bit. It doesn't start turning the orange red until it gets deep into the penumbra. This is going to be, well, anyway, the moon's not going to be totally eclipsed, as I said earlier, but there is a great opportunity for this eclipse. It's going to be very near the Pleiades. Somebody somewhere is going to get an APOD with this photograph. It might as well be you. If you have a 200 millimeter lens or less and a full frame camera, you can get both the Pleiades and the moon in one shot. So full frame DSLR, for example, you might could try this on a tripod. I might try it on a piggybacked on a telescope or with a tracking platform, so you can go a little bit longer. The fully or mostly fully eclipsed moon is going to be pretty dark, so you're going to want to go for a few seconds. And at this focal length, the stars are going to trail. So yeah, just you know, an interesting astrophotography contest. I know we have a lot of members in this club who are up to that challenge. So anyway, that's a minute on the moon. Get your rest, brew some coffee, and next week be ready for the nearly almost close to total eclipse of the moon. And with that, I'm done. I'll stop sharing. John Pinto, you have some things to tell us about tonight.
Yes,
you ready?
I do. Yes,
All
I do.
right, take it away.
So I'm going to try and move through this quickly so we can get outside and maybe see the launch. So if I go too fast, you know, you can always go back and watch the video. It's going to get posted on YouTube. So what I want to do today is, as you probably have heard, we've been selling the Observer's Handbook through the club at a very great discount. And for those of you who don't know anything about the Observer's Handbook, I figured I'd just show you a brief sample of what it is, because it might whet your appetite to order it next year. Here we go. So the first thing you want to understand is the table of contents, because it actually clues you into what has changed from the previous year. Obviously, they put one of these out every year. So I personally, when I get my handbook, first thing I do is I look at all the new and revised information, especially since I've read pretty much the whole handbook before, and just focus on those things. So tonight, what I'm going to do is just go over kind of a smattering of the parts of the handbook that I find interesting and make the most use of. So the first thing is there is a table of all the principal elements of the solar system. Now, most of you probably don't care about this, but those of you who are running software and want to know the latest osculating elements of the planets and of the minor planets or dwarf planets, there's a page that's printed every year for your use to put into your programs. I like this particular one, this particular page. Let's see if I can get my little highlighter here. There we go. Especially this little section right here. This basically is the heart and soul of all of my programs I've been doing, showing you how to calculate stuff in the sky. So this is really handy to have with you. You know, when your calculator next to you and you want to, oh yeah, what was that formula again? And it's right there in the handbook. Another cool part of the handbook is a great section to explain to you all of the different times that get involved in astronomy. And this little diagram up here is sort of a summary of everything that's described in the 6 or 7 pages in the manual about time, and it explains to you why do we have leap seconds, right? This goes into all of that. So that's a fun part of the handbook. Another part of the handbook that I use quite a bit is the sidereal time formulas here and the Julian date formulas. So these are kind of the shortcuts I talked about in my last talk. You don't have to go through the full calculation from scratch. They kind of give you a starting place that makes it really simple to calculate those two things. Another really great reference in this handbook is this reference about all your telescope parameters, like how do you calculate your focal length? What is the magnitude range I'm going to be able to see with my telescope? How close of double stars will I be able to split with my telescope? And all those kinds of things. So this is a great little page that summarizes all that information for you. Probably the heart of the handbook is the monthly sky guide. So it's always broken up into 2 sections. First section is all about your planets for the month, where they're going to be in the sky, and anything in particular to look out for. And then on the right-hand side, tells you significant things that are happening in the sky for each day. It also shows you what the phase of the moon is going to look like on each day. one of the interesting things I found out recently is that if you hold the handbook at arm's length, this actually will match the size of the moon in the sky. So it actually takes into account the perigee and apogee of the moon. Very, very cool. And then, of course, you get a quick overview of Jupiter's satellites. So you can see some satellites in your telescope, and it will tell you which ones you're looking at. Later in the handbook, I'm not going to include it in this overview, but they do the same thing with the moons of Saturn. Okay, we're just talking about the partial lunar eclipse. Guess what? There's a whole section in the handbook every year that tells you all about every single eclipse that's going to happen, both solar and lunar. So this little diagram here should look very familiar from Richard's presentation. And then this is the diagram showing you which parts of the US and Canada will be able to see the eclipse and how much of it. There's a section on the moon. You don't need a moon map. You got one right here in the handbook. Sun, if you want to know your positions of the sun in the sky, what's the equation of time, this explains all of that to you. What comets are going to be visitable this year, at least the known ones from the past that we have orbital elements for. Obviously, we're always discovering new comets, but the ones that were known before the handbook was published gives you the details of what to expect. There are constellation guides. If you don't remember how to pronounce Auriga or Canis Major, you can quickly look it up here, find out what the genitives are when you're quoting things that are in the constellation. You need to know the genitives. It also gives you a little explanation of what the meanings of their names are. We also do the same thing for some of the more popular named stars. So if you don't remember how to say Betelgeuse or Betelgeuse or whatever the favorite pronunciation is, you can always come here and see it. We have a list of the brightest stars by magnitude. I find this very interesting because most of these stars are what we call navigational stars, stars that are used in celestial navigation. So this is a good list to memorize and see if you can identify them whenever you go outside to see which ones are visible. This is probably a very popular list for those who are doing outreach and people ask you, what's the closest star to the Earth? What can I see that's close to the Earth? So this is a great little table here. And these are the easily observable ones. There's a previous table that shows all the nearest stars, the 52 nearest stars. And also I like that I see Barnard's star here. I know Barbara Harris has a great affinity for that. I thought that was great that was in there. Sections on double stars, multiple stars, carbon stars, all of those pretty stars we like to look at during outreach. I got another one here. The ones that have the differences in color that, again, really pop out when you're doing outreach. People really love seeing these doubles colored stars, and they have a great selection of them here. Variable stars, of course, another great topic that we're always interested in. And basically these four little guides here are probably your most popular, easily seen variable stars. So you can get that here. What are your long period stars, such as Myra, which we just had a great period of it over the summer, where it was pretty bright. Another really interesting list here is, again, great for outreach, where people want to know kind of like, well, what's close, what's far away, what can I see, how far away is it? And it goes from the Pleiades all the way out to quasars. So I like this also as a nice list for observing for outreach. Now I have a wide field telescope, so I actually enjoy this particular list in here. Your things that are really nice to see in wide field telescopes, really gorgeous things. I think one of the favorite ones I think of Richard's is the ET Nebula, which is in here somewhere. don't see it right now. But plenty of targets for you if you have a wide field scope. I know we have some of our members are now starting to get into radio astronomy. So there's actually a section on some targets for radio astronomy. So that's a useful thing to have in front of you. And finally, you have maps of the sky. So again, you don't really need much more than the handbook if you're going to go out observing. And that's it. Hopefully that whets your appetite. And if you haven't ordered it this year, make plans to order it for next year. Thank you.
Thanks a lot, John. And our last mini program, Mauricio, are you ready? We still have a few minutes before we're all going to rush outside to see that launch.
Hey, yeah, I'm going to make this one quick. Thanks for having me on again. Let me just share my screen here super quick. All right, so last month we had a pretty successful outreach event out at the let me look up the name again. It was called the Florida Elks Youth Camp. And actually, Andy Silva took these fantastic pictures that I want to share with everybody. Here's all of us setting up, and you can see my red cones that I kind of used to help me keep social distancing going during the pandemic. And we had a great member turnout. Derek was there with Eric, Leonard, Elaine came out, Andy, myself, and then let's see, I think that's it. If I left anybody out, I apologize, but we had a fantastic member turnout. And then he caught this amazing photo. And this is really what I'm now inspired to try and take some pictures like this during our next big event, because I think this is what we really need to have on our social media page, is people showing up, having a good time under the night sky here with all these wonderful stars. So I'm definitely going to bring out a camera and tripod to the next one and see if I can sneak in a picture like this in between, people coming at my telescope. So to give you an idea of where we did that event, here is Orlando, and we did the Florida Elks Youth Camp event over here in, I think, was it Umatilla? So it was about an hour drive. But we got some really great skies out there. I think it was, if I remember correctly, it was like a half moon or a quarter moon. So it wasn't even an ideal moon situation, but we still had some pretty good seeing out there, and we were able to show off the planets, a couple of star clusters. Andy had I think it was, I don't know if it was the Veil Nebula. He had a nebula on his tablet that he was doing a live feed of. So that was pretty fantastic. So that was a very successful event. Unfortunately, we had a bunch of events scheduled during this, I think, past weekend. And I think most of them got canceled. I was supposed to go out to Fox Lake in Titusville for a youth event. That got canceled. And I think some of the other things that we were trying to plan in Geneva got canceled. So hopefully during the next new moon, we have some better luck with the weather. I did want to just share again with everybody some local spots here in the northeastern part of town. One place that I'm going to reach out to and see if I can get our permit renewed is over here is the Little Big Econ at the Bar Street trailhead over here by Geneva off of Country Road 426. So if anyone lives in the eastern part of town here, this is a pretty decent spot where you can come out to and do some observing. I've gone out with a few members, and I will definitely be trying to do that again with the new moon coming up in early December. Probably I just need to reach out and get that permit renewed. I'd like to get it renewed for the hopefully for the whole club. I don't know if what kind of rules they have for if only an individual can get a permit, or if I can get kind of a broad sweeping thing for everybody, but that would be great. And then of course we have the Seminole Ranch conservation area over here in Orlando Wetlands Park, which is far east over by Christmas. And so if anybody knows the Orlando Wetlands Park, literally right across the way, there is this very open field here that is great for stargazing during the wintertime. It's miserable in the summer because it's so close to the wetlands. The mosquitoes are a nightmare, but I might try and go back out there now that the temperatures are dropping this season. So yes, I'm looking forward to getting back out with events. I think it was a great sign that we had so many scheduled this month. Unfortunately, got canceled, but I think it's a good sign of things to come. So I'm looking forward to that. All right, let me stop sharing here. Thank you, Richard.
All right. Thank you, Mauricio. Yes, I think the weather is starting to clear up, and we're going to see more and more opportunities where we can get through. I mean, for a long time we weren't able to do anything, and this weekend looks spotty. But after Friday looks really good for the next few nights for any lunar or planetary observers or anybody doing narrowband with the moon out. Should be great. So, okay, so we have 3 minutes until a rocket launch, and I know the kiddies want to go out and watch the rocket launch, myself included. So thank you everyone for coming out tonight. Don't forget, next month will be a week late. The holiday party will be on December 15th, and it will be at the Geneva campus. Watch your inbox for details and an RSVP system, and I hope to see many of you there. And bring some scopes out or binoculars, and let's get together again. It's been a long time, and I'm looking forward to it. And then in January, back to the planetarium. So see you all then. Have a good night. Hope you get a good view of the rocket in a couple of minutes. Bye-bye.